Okay, hello everyone. We will start today's talk. People will join whenever we get time. So in today's talk, we will talk about the Lagrangian Hamilton equations of motions, and this is a part of classical mechanics. And you are all familiar with this equation of motion in Newton's mechanics. There, you can simply write Newton's equations of motions, which says that force is equals to ma. M is the mass and a is the acceleration of particle. So the same equations which can be derived from Newton's equation can also be derived using three different forms. One is Lagrangian mechanics, and another one is Hamilton's, and third one is Poisson's equations. So we will see all the three mechanisms today, and then we'll derive the equation of motion using three mechanics, and we will see what is the advantage of these using this technique about the Newton's technique, and we will solve some gate problem based on this concept today. So you are all familiar with that. If you have a particle of mass m in Cartesian coordinate system, like 3D space in which we are living in x, y, and z, then we can always represent the position of this by giving the coordinate x, y, z of the particle. And when we try to find the velocity of the particle, we can simply differentiate the position coordinate with respect to time, and we will get the velocity. So in most of this today's lecture, we are going to use this formalism that whenever you see x dot, that means we are differentiating with respect to time. And there are two double dot, that means d2 x by dt square. So acceleration can be calculated by rate of change of velocity dv by dt, which is simply d2 x by dt square. So this is from the Newton's mechanism that we can always write force as F is equals to ma, since force is a vector quantity, and they are just, I have written here the component of this. Generally, force is and acceleration and velocity, they are all vector quantities. So you can write it as x component of force plus y component plus z component. And the simple one x component can be calculated using differentiations with of one coordinate x. In Cartesian coordinate system, x, y, and z are independent. So you can just differentiate with respect to x, you will see uh, the force. So in case of, if you see a very simple case, you are all familiar with that in 10th class. Whenever you have kind of harmonic potential, like you have a spring in which a particle is attached to that, in that case, the force is directly proportional to how much displacement the particle is taking. So in this case, you can always write as force minus kx with k as a spring constant. And from Newton's law, minus kx should be equals to ma. This one is A here. So I just use that quantity. So equation, so this will represent an equation of motion of particle when it is moving in harmonic potential. So this kind of equation we will derive using Lagrange mechanics and Hamilton mechanics. So if this equation is easy to solve, you can simply solve this equation d2 x by dt square equals to minus kx using differential equation, and then you will get x as a function of time t. This will as a solution of this differential equation. So I think you know how to solve the differential equation of second order. And once you know x, you can calculate v by simply dx by dt. And if you know x and v about the particle, you know everything about the particle, how is it moving and how it is going to change its position with respect to time t. So the basic understanding required for the Lagrangian and Hamiltonian mechanics is we have particles, it may be one or it may be two, and we wanted to know how it is going to change with respect to time t, so x and t. And for that, we know what is this equation of motion of this particle. So using this mechanism, we will calculate these equations of motions. And there are certain kind of system that we will study. One is like conservative system in which energy does not depend upon time explicitly. So if you have written your energy expressions, then there will be no time factor that is appear in your expressions. So if you differentiate energy with respect to time t, it will be zero. So conservative system states that your energy will not going to change time as with time. It just remain constant. And in that case, we can always write the total energy of the system as kinetic energy plus potential energy. At time t equals to 0, this will be the energy, and at time later, it will remain the same. So, in one of the property of this conservative system is you can always write the force as negative gradient of potential energy. Uh, Gradient means differentiation with respect to different coordinate systems. Like x component of your force is del u by del x and y component del v by del x. I hope you know how to calculate the gradient of a function. It is del u by del x in the x cap. So I just write it here, this term, del u by del z in the z cap. So you will calculate the x component, y component, and z component just by taking the negative gradient of force. So this is the property of conservative forces. For example, harmonic motions, if there is no damping in your motion, in that case, your potential energy is given by 1 by kx square. So you can always write your force by taking differentiation with respect to x, which turns out to be minus kx. So so this is the same force that you have initially stated by using the formula that if you have a harmonic motions, then force is proportional to the displacement, and from that you derive this relation. So this same can be derived using the potential energy. Here, so total energy is given by 1 by 2 mv square kinetic energy plus potential energy. And I just write it V as x dot. So this energy is going to be conserved here. In case of non-conservative forces, generally your potential energy, which here just function of x and y z, now it will also become a function of x dot, y dot, something like that. So that, like in damping case, your energy will constantly changing on as a function of time t. In that case, your potential energy will become a function of velocity. And so in that case, you cannot drive your force directly from the potentials. So this is the kind of a thumb rule. Whenever you try to find what is the is your system is conservative or not, you just look at the potential energy and see if you can drive your force by taking negative gradient of u. And if you can drive this, then you have a conservative system. Otherwise, your system is not conservative. So in case of Cartesian coordinate system, kinetic energy is given by 1 by mv square, or v has vector quantities. So you can always write as x component, y, z component. So v square is given by this quantity. I just write vx as x dot and y and z by dot formalism. So this is your kinetic energy in Cartesian coordinate system. So instead of one particle, if you have a number of particles like this, then you just take sum over all these particles with their masses, and you will get the total kinetic energy of your system. And now if you differentiate your kinetic energy with, let's say, I just take one dimension case only. So my particle is moving in x dimension. I will not bother about other dimension right now. So a particle is moving in this direction. So my kinetic energy is 1 by 2 mx dot square. And I have a number of them. So if you differentiate my kinetic energy with respect to x dot, so this quantity is not there. So if I calculate del t by del y dot, this quantity will become zero if my particle is moving in just one direction. Otherwise, it is not zero. So with respect to x dot, I think you are familiar with this partial derivative. So if you have a function like fx, and it is a multiplication of x into y into z. And if you calculate partial derivative del f by del x, then you can simply write yz. But if you calculate total derivative df by dx, then you have to apply chain rule. That first you apply with s, then x as it is dv by dx, and then as it is. So there is a difference between partial derivative and full derivative. So here I have taken the partial derivative of kinetic energy with respect to velocity, and this term will become zero. So only this term will survive, and this is known that from chain rule we are left with del xi dot. You can think of this term as del x1 dot del x2 dot, I as 1 and j as 2. So I am trying to calculate velocity dv1 of first particle with respect to d2. And this quantity is always going to be 0 if 1 is not equals to 2. And if 1 is equals to 2, it is 1. So Kronecker delta is given. This is the normally known in case of partial derivative. So this quantity will give you delta Ij, so you are I replaced by j. So this is your partial derivative of x dot with respect to of kinetic energy with xj dot. So it does not depend upon time explicitly. So if you calculate del T by del T, it will be zero. So if we look at this quantity mx dot, this is nothing plus momentum of your particle. And from that, you can also say that if you differentiate, I think you all learned that d by dt of rate of change of your momentum is given by force of the system. So if you take this quantity, you differentiate with respect to time, then you will get your force of the system ma equation. So you take your kinetic energy and then you calculate the partial derivative with respect to one of the velocity and differentiate with respect to time, you will get your acceleration. And for conservative system, we already know that the force is given by negative gradient of your potential energy. So I just write it for J particles here. So these two quantity are same. This one is equals to this one. And this is what is known as your Lagrange equation. That you can always take differentiation of these two, and when you equate them, you will get the equation of motions. We will see how we will do that. So there is this function L, which is known as Lagrange of the system, and it is given as kinetic energy minus potential energy. This is basically the same way to write the equation. So if you take your Lagrange as L equals to T minus V, then you take differentiation with respect to Sj dot. So your potential energy U is a function of x, something like x squared, 1 by kx squared. It does not have any x dot quantity. So their potential energy will become zero. In that case, if you differentiate with respect to time t, this you will able to get this quantity again. And similarly, if you differentiate with respect to x, your kinetic energy, which is 1 by 2x m x dot square. So this does not have any x factor here. So this quantity kinetic energy del T by del x, del x will become zero. So this quantity will become zero, so only potential energy will remain. So that will give you del L by del xj. So if you put this value by Lagrange equation, so this is the equation you are left with. So instead of writing kinetic energy in terms of kinetic energy, potential energy, we generally try to write equation in terms of Lagrange, and this is the Lagrange equation of motion in case of Cartesian coordinate system. So whenever you see any system of configuration, you just write kinetic energy, write potential energy, take their difference and write this as Lagrange. And from that, solve these equations to get the equations of motions. For example, in case of harmonic potential, your potential energy is 1 by 2 kx square. So you write your kinetic energy, which is 1 by mx dot. So this is your Lagrange kinetic energy minus potential energy. Then you calculate del x by del x dot, this quantity. And then you calculate del by del x. And just put inside these expressions of equation 5, this quantity, you will left with these equations of motion. So this formalism is very general in the sense you just can be applied it to any systems. Just write kinetic energy, potential energy, their difference, and solve these equations, and you will get the equations of motions. So why we do that? I think you are all familiar in your 10th class that for different kind of configurations, you have to solve different equations. For example, if you have this configuration, then you calculate the one force in that some direction, another force in some direction, and try to compensate these forces. Similar case in case of pendulum. You calculate the tension and then you take its component in different direction and one gravity force and try to compensate this. So instead of doing all these things, all you have to do is write the kinetic and potential energy and solve the equation and you will get the exact same equations. So you do not have to do this thing again in this case. Another case is sometimes we do not know what is the force in our system. For example, if I will give you some classical system and I say that you have to just move that particle in circular motion and you have not given any other information, just that the particle has to be moved in circular motion. So you do not know initially you know, what is the force that is acting on particle. There is some knowledge that you say that some centrifugal forces are there, but if you do not know these forces are there, how do you calculate the equations of motion? So there you can also find that the Lagrangian formalism is very important since you do not have to know the knowledge of forces to be known exactly initially. So, for example, this is the questions here. So, if you have a particle which is moving in circular motions, and you have to calculate what is the equations of motion for this case. So, we do not know exactly, you do not know what is this kinetic energy. You can always write kinetic energy like x dot square plus y dot square. There is no z here, but you do not know is it moving in x direction or y direction. So you have to change your x and y to some other coordinate system like polar coordinate systems. There you instead of writing as vx or vy, you write your equation in terms of radial coordinate and theta coordinates that we have also talked about in case of central forces, where we use the polar coordinate system to solve the equations. So there also your Lagrangian, which is here, is given by del L by del x dot. So Lx dot is your Vx. So this quantity will then replaced by your VR. So your Lagrangian formalism is also flexible with the change in coordinate system. So even if your coordinate system will change, your Lagrangian will still be able to calculate. For example, in polar coordinate, we generally write x as r cos theta or phi and y as r sin phi. Here I have taken phi as its angle. So if you look at the, it is the angle phi which is changing with time as a particle move along the surface. So phi is the coordinate which is known as a generalized coordinate or generalized velocity for this case. So we have to write the Lagrangian equations. And in case of generalized system, we just write it as Q. I have just write Q to be, more of general case. It can be X, Y, Z, or it can be R, theta, phi. It could be anything. So just this is the most general form of Lagrange equation. So here, if you look at your XY coordinate, you can write your Lagrangian in Cartesian coordinate as x dot. So you calculate your x dot using differentiation of with respect to time. So again, chain rule, differentiate R and define Y component. Similarly, you calculate Y dot. But one of the conditions that you have given is your particle has to move in a circle. So your R is not changing with time. It is fixed. That means R dot is going to be zero. Your R is not changing with time. So this will give, if you put this value here, this will give you x dot and y dot. And when you put the value in terms in your Lagrangian, which is 1 by 2m x dot square y dot square, this will give you equation, which is again turns out to be in terms of phi dot. So you can see you started with an initial coordinate system which is xy. Your final coordinate system is phi dot. So your Lagrangian is a function of a generalized velocity, which is phi dot. So you just write your Lagrangian equation of motion, and your q is phi here. So just del L by del phi dot. When you calculate del L by del phi dot, you just differentiate with respect to phi dot. This quantity will become m1 square I dot. And similarly, there is no phi dependence in this case. There is only phi dot here. So when you calculate del L by del phi, there is no phi functions, so it will become 0. And when you put back into this Lagrangian equation, d by dt of this will become your equation of motion. So even though you do not know here the force initially, still you are able to write the equation of motions. And see, in that case, m is constant, r is constant, and this is like acceleration in angular direction. So your angular direction acceleration is 0. That means your phi dot is kind of constant. So your particle is moving in a constant velocity if it is have to be in a circle. So this is how this Lagrangian formalism is important. Similarly to Lagrangian coordinate, so I think you will understand the concept of generalized coordinate. Generalized means it could not be an XYZ, it could be anything, R, theta, phi, कुछ भी. And then this is replaced by Q here. So this Q is your generalized coordinate. Similarly, you have generalized momentum. Initially, you have learn about these things of, you know, momentum px, which is given by m dx or m into dx by dt. So this is your coordinate momentum in just x direction. But if you have coordinate system r theta phi, then you have to write the momentum in that coordinate system. So this is where generalized momentum is helpful. So we will write generalized momentum using a coordinate p. Similarly, to like generalized coordinate is represented by q, generalized momentum by p. And like in this case where one particle is moving in one dimension with potential energy Vx and kinetic energy and V square. So your momentum is given by, if you differentiate your Lagrangian with respect to x dot, it will give you mx dot, which is simply mv. So this is become your linear momentum. So whenever you have a Lagrangian, you just differentiate it with respect to your del q dot and you will get your momentum. So this is known as generalized momentum. And it is always going to be conjugate to your coordinate q. So for example, in initial case, our q is phi. So if you look at your Lagrangian, which is given by this quantity, 1 by 2 mr square phi dot square, you differentiate it with respect to phi dot, and it will give you mr square phi dot, mr square phi dot. So this is your generalized momentum in this case, mr square phi dot. And this is constant since your phi dot is constant. So it means in that system, your momentum is going to be conserved. So you have understand two definition. One, not two, three. One is Lagrangian, which is given by kinetic energy minus potential energy. Another one is Q is a generalized coordinate, so you can apply any coordinate system. Similarly, you have P, which is generalized momentum. So now come to, this is all about the Lagrangian, from which we can calculate any equations of motions. And similarly, there is this Hamiltonian formulation, which is similar to Lagrangian, but a little bit more advanced in the sense our Lagrangian is a function of generalized coordinate q, generalized velocity q dot, and generally we write our Lagrangian like that. But our Hamiltonian is a function of generalized coordinate q and momentum. So we have to change our coordinate system from q dot to p. So whenever you try to change your one of variable, so you use always Legendre transformations. So what Legendre transformation does is it will change your q dot to p and it will give you some condition how you can derive your Hamiltonian from your Lagrangian. So for example, in case of thermodynamics, this Legendre transform is used to change your Helmholtz free energy to Gibbs free energy. Helmholtz free energy is a function of, temperature and volume. But if you wanted to Gibbs free energy, so you wanted your function, it would be a function of pressure and volume. So what it does is it just add one more constant PV. P is the one for which you want your system to change and V is the ones which you want to eliminate. For example, in this case, I want to eliminate Q dot and I wanted to add this momentum. So if I will take PQ dot and we just add this term in our Lagrangian, then it will give you our Hamiltonian that we will see here. But here it's not the addition. Here, if you look at almost reality, they have all negatives. So you just add PV here and you just differentiate it, and that will give you your this free energy. But that is the concept of thermodynamics. Here we have the Lagrangian that we wanted to change to Hamiltonian. So you just add PQ dot in your Lagrangian, negative of that. But here is already negative quantity there, so we just add it. So the sign has to be different so that you can cancel some terms. And this one is for I number of particle. You just add summation. We will do the calculation for one particle. So you just take differentiation of these. Again, apply chain rule, one with p respect to p and another with respect to q. So if you look at your Lagrangian here, the Lagrangian is a function of q and q dot. So it will apply a chain rule. If you calculate dl, that means you have to calculate with respect to q. That will give you pq, and then with respect to q dot also. And if you know that del L by del Q dot is given by your Lagrange momentum, so you replace this term here. This will cancel your one of the term in your DH. So your Hamiltonian will become like this. So and this your Hamiltonian equations. And if you take your DH and you differentiate with respect to P, you will get Q dot. And if you take DH with respect differentiate with respect to Q, you will get minus P dot. And again with respect to t, you will get del L by del t. So these are the Hamiltonian equations of motion. So you write Hamiltonian of your system, which is given by pq dot minus L. So first you have to write Lagrangian. From that you will derive your Hamiltonian, and then you write your Hamiltonian equations of motions. And this will again give you same equations like ma equals to minus kx. For example, for a motion of particle in one dimension, kinetic energy plus potential minus potential energy. So your momentum is del L by del x dot. So you write your Hamiltonian, which is PQ dot. So you derive your P, Q is x here. So your Hamiltonian will become Px dot minus L. And you just write here that from this x dot is given by P by M. So replace your x dot by P. So generally, replace your x dot by P. So this will become your Hamiltonian. And if you look at this is the total energy of your system. So your Lagrangian is T minus V, but your Hamiltonian is T plus V. And in conservative system, it will represent the total energy of the system. And whenever in gate question you encounter the Lagrangian, try to write the solution which have these two coordinates Q and Q dot and Hamiltonian which have coordinate P and Q. So this is the main concept. Even though both give the same equation of motion, but in one case it is written in Q dot, in another case it is written in terms of momentum. So this is your Hamiltonian equations of motion. So once you return Hamilton, you just of motion. You differentiate with respect to P, put it equals to Q dot. So this is the first equation, Hamilton equation of motion, and differentiate with respect to Q, put equals to minus P dot with respect to Q and equals to minus P dot. So this is again, if you know minus dV by dx is nothing plus the force, and it is equals to rate of change of your momentum. So this is again your 10-second law of motions. And third way to calculate this equation of motion is Poisson's equation. So Poisson's equations of motions, it's not the same as we encounter in, you know, electrostatics. There also there is a Poisson equation, but it is different here. So basically we have to calculate some Poisson brackets, and what this Poisson bracket is, that is the main point here. For example, if you consider a function f, which is a function of p and q, so it's like Hamilton, which is a function generally of p and q. And also if you consider a function of how a system is going to change with respect to time t. And Poisson bracket is defined as you take your system if you have two different functions, which is a function of P and Q. Always remember there has to be a functions of P and Q. If they are only function of Q, the Poisson bracket will become zero. Or matlab means if there is same coordinate inside them, then it will become zero. So your Poisson bracket between two variable is you take your first variable, differentiate with first coordinate, and differentiate second variable with respect to momentum, minus take your first one and differentiate it with respect to momentum, and take your second term and differentiate with respect to Q. So this will become your Poisson bracket. If you have n number of them, then add whole of these terms like this. Summation of I means you add for n number of particles. So Poisson equation will tell you how your system is going to change with as a function of time. So there are three things. So basically, in summary, if you understand clearly, there are Newton's law of equations, which we generally write F is equals to ma. And this is a traditional way which you have learned in your 10th class. The same formalism can be used to calculate more complicated system. And for that, we will use Lagrange, which is kinetic energy minus potential energy. We write equation of motions using Lagrange as del L by del Q dot minus del by del Q equals to 0. And we can also derive momentum P as del L by del Q dot. And from that, we can also write our Hamiltonian, which is PQ dot minus L. In conservative system, this term is turns out to be kinetic energy plus potential energy. And then we can also write equation of motion in terms of Hamilton's, which is del S by del Q. I think del S by del Q equals to minus P dot, minus P dot. So we have minus P dot and del S by del P equals to Q dot. So these are two equations. And the third formalism is the Poisson bracket, which is also the equations of motions. And we can just calculate the Poisson bracket between two variable A and B by del A by del Q del P by del P. Try to write this to have a form of PQ so that one of the quantity will not become zero. So these are the just summarize. Now we will solve our gate questions. So in this questions from 2000 exam, the Lagrangian for a simple pendulum is given. So you are given a Lagrangian. So if you look at your Lagrangian, it is a function of theta dot square and theta. That means your coordinate this system, which is Q, is theta here. And now we have to calculate the Hamilton's equations of motions. So to calculate the Hamilton's equations from Lagrangian, what you have to do is you have to know PQ dot minus L. You know your L, but you do not know what is your P. So you just differentiate del L by del theta dot. It is will give you P, and you write your theta dot in terms of P. So just put this value here, P into theta dot, and P is replaced by ml square theta dot, and your Lagrangian as it is. And you just replace all theta dot by P, since your Hamiltonian has to be in terms of P and theta. You just solve it, and then it will become your Hamilton's. But you have to calculate Hamilton's equations of motion. Differentiate del H by del P and del H by del theta and put equals to theta dot. That will give you first equations of Hamilton's, and this will give you second equations. They are just formula based question. If you remember these formulas here, these are enough to solve all your gate questions that has appeared in previous years. So you have to say theta dot is equals to p theta dot, p theta ml square, and p theta dot is minus mg theta. So this is correct answer here. So we have to calculate also the Poisson bracket between theta and theta dot. So You are you have to calculate theta and theta dot. So it will be great if you can write your boson bracket in terms of quantity which are theta and p. So try to write your boson bracket in terms of quantity which are q and p. Now you this become a and this become b. So you just differentiate it. See, ml square is not depend on any of p and theta, so it will come out of boson bracket. And this is just like differentiation, one with respect to theta, p theta, and then theta with this one. So this is the definition of boson bracket, that del A by del Q, del P by del P. So A is theta, B is P theta. So this will become one. And now del A by del P. That means del theta by del P. Theta and P has no dependence, so this term is zero. Similarly, del P by del Q means del P by del theta. So P and theta is also does not have any dependence. So from there we will calculate the boson bracket 1 by ml square. So this is the correct answer here. And this one is also from GATE 2012. You always going to encounter at least one questions from this topic in every GATE exam. And if possible, there might be two or three questions from this single topic. From that perspective, this lecture is very important. In this question also, a particle of mass m is attached to a fixed point O by a weightless inextensible string of length A. It is rotated under gravity as shown in figure, and Lagrangian of the particle is given, where theta and phi are polar coordinates. So what is the Hamiltonian of this particle? Now, if you look at this question, it is given that theta and phi is the main coordinate in your Lagrangian. That means theta and phi are your generalized coordinate. So first question, this one you have just one coordinate. Here you have two coordinates. So you have to use summation equation here. And it is given to you the Lagrangian of the system. And Hamiltonian is given by, for one particle is T dot minus L. But if you have more than one, not one particle, for one coordinate system. If you have more than one coordinate system, you have to summation over these. So you have two. So you have P as theta and P and phi. Similarly, you have Q, which is theta dot and phi dot. And this is your Lagrangian, which is given to you. So you do, for calculating Hamiltonian, you need to know the knowledge about P theta and P phi. So from the Lagrangian, del L by del theta dot will give you P theta, and del L by del phi dot will give you P phi. So you take your Lagrangian and differentiate it with respect to phi dot theta dot. So your theta dot have only one dependence, which is ma square theta dot. So from there you calculate the relation between theta dot and p theta. Similarly for p phi, you differentiate your Lagrangian with respect to phi dot. So this is your differentiations. From there you calculate the relation between phi dot. So in your this formula, you just replace theta dot and phi dot by these relations for theta. And once you put these values, you solve for, means kind of solve more generalized way. And this will become your Hamiltons. So 1 by 2 m square, p theta square plus p phi square by sine 2 theta plus and ga. So this will be your correct answer. And this was also from GATE 2012. The two questions are from this same topic. So you see in 2012, three questions are appear, are there for there in this question from this same topic. So in this question, a particle of mass m slides under gravity without frictions along with the parabolic path y equals to ax square as shown in figure. Here a is constant. What is the Lagrangian? So in this question, we have given trajectory of this particle. Y is given as a function of ax squared, and we have to calculate Lagrangian. So whenever you have to solve some problems in which we have to calculate Lagrangian, initially start with writing simple equation of Lagrangian, which is 1 by 2 m x dot square plus y dot square plus no, plus minus potential energy. So this is your kinetic energy, this is your potential energy. X dot square is known since you have given y, so you just differentiate with respect to time t, you will get y dot, and by putting this value, you will get your kinetic energy. Now, if you potential energy, so the potential energy is given by how much mgh is generally in the case when height is h. Since height is y here, so it is mgy. The potential energy is mgy. There is no dot here. So y is given as ax square. So a potential energy is also become ax square. So Lagrangian is d minus v. Now, if you look at your Lagrangian, it just have x and x dot. So your Lagrangian is a function have one generalized coordinate which is x. So
जी
your
मैम.
Lagrangian equation of motions is just form. Yes, sir.
हाँ मैम, इसमें जो पोटेंशियल एनर्जी है वो नेगेटिव नहीं होगी क्या?
No, generally it's about the surface. It, no, in that case, generally you have calculate the.
ओके ओके, वी
Okay,
आर.
so you are saying about the surface.
ओके ओके. अगर ये मतलब नीचे होता ना, ये पॉइंट एक्स एक्सिस के नीचे, तब
In that case, y is already negative now. So if you have some point here, in that case, y is negative.
क्या?
Okay. So this is your potential energy. So this is your Lagrangian. 1 by 2 m 4x square minus. So this is your Lagrangian. And you have to calculate Lagrange equation of motions. So this is your Lagrange equation of motion. Differentiate with respect to x dot and differentiate with respect to x and just put in this equation and you will get Lagrange equation of motion. This is the correct answer. You can solve it with simple mathematical manipulation. And this was question from K 2013. The Lagrangian of a system with 1 degree of freedom is Q is given by this. So you have just one coordinate which is Q. The alpha and beta are non-zero constants. If PQ represents the canonical momentum conjugate to Q, so basically this same momentum, then which one of the following statement is correct? You have to find the value of PQ and find if the system is conserved or not. So Lagrangian is given, PQ is given by del L by del Q dot. So this is your momentum to alpha Q dot. So only these two options. So for conservation of momentum, you have to just differentiate your momentum with respect to time t. If it is zero, then the system is conserved. If it is not zero, then it is not conserved. So if you look at here, this is del L by del Q dot is your momentum. So if you calculate del L by del Q dot and differentiate it with respect to time t, which is like calculating this quantity, then from Lagrange equation of motion, it is equals to del L by del Q. That means if you calculate del L by del Q, which is not zero here, that means your system is not conserved. So this is the correct option. So you will encounter these types of questions again and again in GATE exam. And if you understand this part, you will can solve every question related to this concept. So if you have any doubts, you can ask from any part of the lecture. If you have any doubt, you can ask simply.
Then,
Yeah, yes.
do you have classical notes?
Oh, means complete notes of classical mechanics out
Uh,
of this concept.
complete notes.
No, actually, I do not have for classical, but I can try to find some for you because there is nearby place IIT Delhi. I can
Oh,
find from there.
okay, man.
I will try
Excuse
to.
me, madam. Can you,
Yes.
excuse me, madam, can you please share the links that you shared before?
Okay. For the YouTube link for the notes.
Yes, madam. The both.
Okay, I will share the YouTube link again. You can find all these notes in this YouTube link.
Then we have also create a Telegram group for NPTEL lecture.
Okay, so then you can share, you can add me, and then I will. How can I find the people there?
पर मैंने ऑलरेडी टेलीग्राम लिंक शेयर कर रखा है यहाँ पे।
Okay,
कल मैम के साथ मैम ने बोला कि आप मतलब कि एक टेलीग्राम ग्रुप वगैरह ज्वाइन कर लो ताकि मतलब स्टडी मटेरियल वगैरह वहाँ से शेयर कर सके।
okay. This one is Telegram link that you have shared. Okay, huh. So I can share these notes there also.
मैम एक बेड जो स्लाइड वाला एग्जांपल है ना, बेड स्लाइड कर रही है,
Oh,
उसका लैग्रेंजियन वगैरह
yes.
उसका लैग्रेंजियन वगैरह कैसे निकलते?
उसका
लैग्रेंजियन कैसे निकलते?
लाग्रेंजन कैसे निकालना है?
नहीं नहीं, ये वाला एग्जांपल नहीं, मैं मेरे पास अभी 3-4 दिन पहले पहले था, उसमें एक बेड स्लाइड कर रहे थे।
Okay. So you can do one thing. You people can share your question on this Telegram group, and if I will find every Sunday, I will try to give you solution of that questions.
ओके, you you will join our telegram also, yeah?
Yeah, I have joined your group.
Okay then, thank you. We will share some problem related to classical mechanics, okay? अब मैम एक
Okay.
ईएमटी का एग्जांपल और है मेरे पास।
So EMT can
क्या
also share on this group. I will try to solve the problems.
मैम एक क्वेश्चन ये डिस्कस हो सकता है, मेरे पास एक पैरेलल कैपेसिटर है, ठीक है?
Okay.
उसके बीच में एक चार्ज है, वो चार्ज
Yes.
राइट प्लेट की तरफ से मतलब वो हो रहा है, डिस्प्लेट हो रहा है, उसका डिस्प्लेसमेंट है राइट प्लेट की, ठीक है?
Then it will start simple harmonic oscillation. If it is have a slight movement towards one of this plate, then
एक
there
तरफ
will
एक
be
प्लेट, एक तरफ एक प्लेट की तरफ हो रहा है।
uh, just because imbalance of this force. So it will start simple harmonic
तो
oscillation and
क्या
that you have to
उसी
solve.
में
Okay.
उसमें ये से दे रखा कि वो उसी प्लेट की तरफ से ही करेगा, उसी प्लेट की तरफ, ऐसा
So
आंसर दे रखा है।
so what you wanted to find in that question?
बस ये चार्ज थोड़ा सा डिस्प्लेस हुआ है राइट प्लेट की साइड में, तो आगे उसमें 4 ऑप्शन दे रखे हैं, इट विल ऑक्सिलेट, इट विल मूव टुवर्ड्स राइट प्लेट, इट विल मूव टुवर्ड्स लेफ्ट प्लेट, ऐसे ऑप्शन दे रखे थे।
Yes, generally what happen if you have that kind of conditions, na, you have a parallel plate capacitor. If your charge is placed in between, there will be stability since equal forces are there. But even a small displacement can lead to oscillation of this particle in simple harmonic motion. and then you have to solve this again for calculating whatever you have been asking question. I have one question like that in my notes. I will share with you.
Okay.
Okay, someone, why you people have shared these email IDs? You can find all these notes on this YouTube channel. So I will upload the video and also the channel. The notes is also available there.
Okay, ma'am.
Okay.
The
If
next
you
class with
have, so is there any specific topic that you people want me to cover?
uh, uh, potential motion in potential energy
What?
stability वाला equilibrium वाला point है ना वो उससे related
Okay, okay, that one, the equilibrium configurations in which you have potential energy and you have to find different configurations for different potentials.
yes ma'am.
Okay, we will do that in next class if that one is an interesting topic. Hello.
Okay ma'am.
Okay, thanks for the topic. Okay, see, then bye bye.